All right, this is the extra examples from section 2.6. Starting with solve the inequality and express the solution in terms of the interval whenever possible. We're going to be looking at B. We need to get, since this is a compound inequality, you have two different inequalities, we need to get x by itself in the middle. So the first step is we're going to multiply everything on all three sides by 3. So that would make this -6. The middle would just become the 4x plus 1, since the 3 would cancel if you multiplied by it. And anything times 0 is still 0. I would then subtract 1 from all three sides. And then divide everything by 4. So we're getting -7/4 is less than x is less than or equal to -1/4. In interval notation, that would be a parentheses, -7/4, comma, -1/4, and then a bracket because of the equal to bar closest to the -1/4. For D, it's a little different. This fraction does not go across the whole middle. So if it was me, I would actually start by subtracting 3 from all the sides. So that would make this -5 is less than 1/4 x less than or equal to 2. Then we can multiply everything by 4. So this would be -20 is less than just x is less than 8. Now x is by itself, so this would be -20 with a parentheses up to 8 with a bracket. Again, the ending has a bracket because of the equal to. For E part, we need to FOIL this out. So this would be x squared plus 3x minus 3x minus 9. This is also going to need to be FOILed since it's x plus 5 times itself. So that's x squared plus 5x plus 5x plus 25. This would be x squared minus 9 greater than or equal to x squared plus 10x plus 25. If we move the x squareds over, trying to get them on the same side, they actually cancel out completely. So this is -9 is greater than or equal to 10x plus 25. I like usually to have my x on the left side, but I'm just going to go with this right now and we can fix it at the end. So that is -34 is greater than or equal to 10x. Divide both sides by 10. Reduce your fraction by dividing top and bottom by 2. And now notice I don't like x to be on that side, so I'm going to flip it around. So this is x is still pointing to the x, less than or equal to -17/5. In interval notation, that would be -infinity, since we're going less than, up to -7/5 with 17/5 with the bracket. So there's the answer to that one. We talked about absolute value inequalities. If you have a less than, you put the argument in the middle and have it set between the -a and a. If it is a greater than case, we have the argument inside is less than the negative case, or the argument inside is greater than the positive case. We didn't go over the reciprocal property in class because I told you that's a lot to remember. I actually solved these just the same way we did in section 2.7. So I'm going to use the 2.7 method of solving when possible. Okay, so remember we find our critical value here. There's no critical value on top because there's no x. So this would just be -5/2 is the only critical value. So this is kind of jumping ahead a section, but I find that the reciprocal property usually confuses people if they don't know how to set it up. So this right here cannot equal 0 because it's in the denominator. So we're going to let this be open. And then this is -infinity to -5/2 and -5/2 to infinity. Pick a test value on each side. I would pick 0 on this side and maybe 4 on this side. And you just plug it in. Now 3 does have to be listed because that's our top factor. But it's 3 and 2x plus 5. And we hope that it comes out less than or equal to 0. 3 doesn't change the 0. The 0 doesn't change 3 at all. It also doesn't, 4 doesn't change it because that's just a number. So 3 is always going to be positive. This will be 0 plus 5, so that's positive. So 2 positives is a positive. And this is also positive. Wait. Oh, I did this wrong. Sorry. The one thing I told you guys to be careful of. Let's refix our interval. 0 is not less than negative 5/2. See how easy it is to do that? So even I make that mistake sometimes. You have to pick something in the interval, and I was just thinking 0 because I saw a negative sign, but we're actually at negative 2.5 already, so we have to use something negative, so negative 3. This side we could use 0 on if we wanted to, so we could also keep it a 4. But remember, whatever number you pick for your test value has to be in those intervals, so be careful because it's easy to do. But still, the 3 is going to be positive no matter what. The number has no x attached to it. But negative 3 times 2 is negative 6 plus 5 is negative 1. So that's going to make an overall negative for that column because positive times negative. 0, though, will give us another positive. So since we want less than or equal to 0, this is the interval we want. So the answer is negative infinity to negative 5/2. Okay, so let's look at this one. This is a little different because there's a negative out front. So I'm going to put that up top with that 3. So this time, and I'm going to work over here, my critical value, if I set the bottom equal to 0, that would be x equals 2. So I just added the x over. So I have a number line, and the only critical value is a 2. It has to be an open circle because it's in the bottom. And then my intervals are negative infinity to 2 and 2 to infinity. My number of choice here, I'm going to choose 0 in this interval, and I'm going to choose 4 right here. So those are my test values. Be careful. You have to include that negative 3 as part of your factors because it is affecting the sign. And then 2 minus x is my other factor. And this time we want to be less than 0. So negative 3 is always going to be negative. There's no x attached to it. 2 minus 0 would be a positive 2. 2 minus 4 would be a negative. So negative times positive is negative. Negative times negative is positive. We wanted less than 0, so it is negative infinity to 2. So we can, even though there's not much to do here, you pretty much just get a number and then something on each side that you have to test. C is a different creature completely. This bottom can never be negative. It can never equal 0. It can never be negative. Because if you square something and add 4 to it, it's going to be positive. So this bottom is always positive. The top is a positive 4. This question is a trick question. This fraction will always be a positive over a positive. How can a positive ever be less than 0? So this has no solution. So sometimes they'll throw something like that at you where it's not even solvable because this fraction can never have a negative outcome. Therefore, it can never be less than 0. So, and the reason you can't really solve this one is if you try to factor that, it doesn't factor. It's got imaginary solutions. So it's not going to work out the way these other ones have. Okay, then we had 2 or 3 more left. So this is the absolute value with a less than. So we take our argument. We place it in the middle using the same symbol twice, this symbol right here, between negative 7 and 7. There's nothing to solve on this one, so the answer is negative 7 with a bracket to 7. So less than should always have a number and a number as the starting and the ending. This one's a greater than case. For greater than, you have 2 cases you set up. You keep the argument and you make it go to negative infinity by doing less than a negative, and then you keep the argument and you keep it the other way, which is greater than the positive. So one case you leave the inside alone, you change everything else. The other case you leave the inside alone and you keep everything the same as the original. So when we solve this, though, even though we set this case up to be the negative and that case up to be the positive, we have to divide by a negative x. Or negative 1, not negative x. We don't want to move the x. We just want to divide by negative 1. So this is x is now greater than 2, and we divide this one by negative 1, and that is x is less than negative 2, since we divided by a negative. So the less than case is negative infinity to negative 2. The greater than case is 2 to infinity. Now, I can't remember if I did this one in both classes, so I'm going to make sure we talk about it. If you have an absolute value, that is always going to be something that comes out positive. An absolute value that is positive can never be less than a negative. A positive can never be less than a negative, so this is no solution. Positive can also not equal a negative since there's the equal to sign. That's the end of the 2.6 video.